Digital pictures these days are the ultimate economy. They're really, really cheap. They have almost no cost whatsoever. And so it's important to, if you want to try and do this, just start. It doesn't matter how you start or where you start. I'm going to show you some of the ways that I would recommend that you start. But if you don't take pictures, if you don't want to take pictures, that's fine. I'm not trying to say you have to take pictures. But if you want to take pictures, just try something. Because what you'll find is when you take a picture and you look at it, you say, oh, that's really nice. Or you'll say, oh, no, it's not. And if it's not, then you can figure out what you have to do to make it better. And so as you go take more and more pictures, your skill will get better and better at it. If you want good pictures, if you want to see pretty pictures of things in space, go on the internet. Go to the Hubble Heritage Center. They have much prettier pictures than you or I will ever take. Well, maybe for the next 5 or 10 years anyway. You'll find better pictures there, and if you just want pretty pictures to do something with, put up on your wall or your screensaver, go on the internet, you'll find it. But there's something very satisfying about being able to take your own picture and show people what you see when you look through the telescope. It's very difficult to get some of our friends to come out at night and in the cold weather, gaze through the telescope. Quite frankly, the view sometimes through the scope, unless you've got a really big behemoth, the view through the scope isn't as impressive as some of the things that you can take. So if you want to share what you see at night with people, take some pictures. It begins with knowing how to use the gear you have. That could be something as simple as a tripod and a DSLR, a simple camera. Or maybe your iPhone. I'm going to show you in a little bit how you can take pictures with your iPhone. But it just begins with the equipment you already own. Analyzing the images, once you've taken a few, look at them and see what you need to do to make them better. It's all about a test, analyze, and fix process where you're trying to understand how what you've taken isn't quite capturing what you want to show. So you want to make them better. I have to tell you seriously though, as you go do this, it's going to place serious strain on your self-restraint because you're going to want to go do more. You're going to want to take better pictures. You're going to want to buy that next big whiz-bang, gee-whiz kind of thing that's going to solve that problem that you have. I'm urging you not to do that. We'll talk more about that in a minute. And slowly over the years, I got the mount, and then I got the guider, and then I got this thing, and then I got that thing. Right now, I've got some really nice gear that allows me to take some pretty nice photographs. This is an apochromatic 160 millimeter scope by Tech Engineering. This is a 180 millimeter reflector, Newtonian, by Takahashi. And when you put all those things together, I can get 4 degrees on a field of view of sky, so I can capture big swaths of the sky. This is a highly accurate thing. I can get accurate pictures. But you don't have to do that now. I mean, you don't have to start there. You can't start there because there's a lot of money involved. And I'm urging you to start with the things that you already have. A camera on a tripod and take pictures of the sky. What you're going to find is some really pretty effects. As the stars rotate throughout the night, you're going to see star trails. If you point that at the North Star, you'll see the North Star is stationary and the stars are going to rotate around it. We'll show you some of those a little bit later. The next step, I guess, in the complication is to take this camera and put it on the back of your telescope. You have a telescope that tracks the sky, even in a passive way, just a clock drive. Then you'll reduce or eliminate some of that smearing and movement of the stars in the sky. You get some very nice pictures with long duration. The next option is to do what you call prime focus. You take your lens off, gently setting it down, and you put an adapter, a T-ring on there. Carefully lining it up so you don't strip anything. Put your T-ring on there, and then this goes into the eyepiece of your telescope. Right now I have a telescope with a 2-inch eyepiece, so that fits into the eyepiece of the telescope. And you essentially have what's called prime focus photography. You're using the telescope as the lens of your camera. So you wind up with, in my case, a 120 millimeter telescope lens instead of the probably 100 millimeter telescope lens. Again, when you get that kind of magnification, you have to have some sort of tracking mechanism or take very short exposures. But that's another way to do it. Sometimes this system won't come to focus And so you'll need an adapter. It slides on there, and it brings the camera further away so that you can bring it to focus. But these are relatively inexpensive adapters that you can buy from places like Hands-On Optics and make it work. There are other ways of doing it. For example, you can have afocal coupling. If I take my eyepiece and I put that in my telescope, and then I put an adapter on there and tighten it down, I can then take my iPhone, okay, line up the camera, stick it in there, tighten this down, and then using the camera on the iPhone, I can actually take pictures through my telescope of fairly bright objects, fairly simply. This is called afocal coupling, taking the eyepiece, using the eyepiece to bring the image to focus on the camera. You don't have to use the iPhone. There are other adapters that you can use to put the camera in place. This happens to be one of them. This eyepiece is too big to fit in there. But if I open that up, I can fit a smaller eyepiece in there, put that in, secure it down. Okay. Gently put it on there. And then this is a camera adapter, just like I put on the thing there. It's a standard T-ring. And I put my camera on here, and now I'm using my eyepiece to magnify the view that goes onto my camera. Again, you're going to get fairly high power, high magnification images if you do this. So, you need to take either really short images, like a bright object like the moon, or you need to have a guiding camera that tracks the sky. But it's just another way to do it. I wouldn't recommend that you get started using that, but as you get further into the hobby, it's another way. Then you can put Barlows and compressors in there to increase or decrease the magnification. A lot of different ways to make that happen. But the simplest way to start is either on a tripod or on the piggyback on your telescope. Once you've got a way to track the sky, putting the camera body on the back of your telescope using the adapter like you see there. Anyway, long duration mediums, basically all you need is the camera, like we talked about before. I recommend a DSLR, but other cameras can be used. If you're into film, you can do that. It has its drawbacks, but you can use that. And then some sort of a lens, some sort of a lens for it, and then putting it on a tripod. Just take pictures of the sky, and we'll show some a little bit later. You can see them rotate. The other thing we're going to talk about each of these in more detail. Bright solar system objects, planets, the moon, comets, things like that. They're pretty bright, and you can usually do it with basically the same kind of gear. As you get into more detail, taking pictures of wide field of view, of asterisms or constellations, again, it's just a matter of changing the different kind of lens. In some cases, when you're taking pictures of stars like that are relatively faint, you may want to get into some sort of a driven scope, some sort of clock drive, and as long as you keep the exposures fairly low, and we'll tell you what that means in a few minutes, you can usually do that with a driven mount. When you start taking pictures of deep sky objects, you need all of that above, but you certainly need a driven mount, and you may in fact need an auto guider, something that keeps the star, keeps the field of view in precisely the same place on your telescope on your camera. Here's a picture of Polaris. See Polaris right there. And here's the Big Dipper, right up here. Again, it's smeared, but it's kind of pretty. And it makes for a good screensaver or something to share with your friends to show them that the Earth does indeed rotate. In fact, when you're taking pictures like this, you'll see meteors going through, you'll see satellites going through. You could, if you time it right, even potentially see iridium flare, which is another whole topic, but they're satellites that are reflecting the glow of the sun on a spot on the ground, and you can capture that. So to do this, again, you need a moderately steady tripod, you need a camera with a good battery. And that becomes a problem in the wintertime, because the cold weather will drain the battery fairly quickly. One solution is to have multiple batteries. But the solution I use, or solution I like to use, again, costs a bit of money, but it works. This is an adapter that fits into the battery compartment of my telescope, and this is the other end that fits into a cigarette lighter, 12-volt battery that I use, and there's a converter in there that converts it from 12 volts to whatever power you need. I can photograph all weekend long without having to worry about my battery dying using something like that. Multiple ways to do that. Depending on what you want to take a picture of with stars, you have to choose a lens that's consistent with the field of view that you want to take. This one happens to be a 100mm lens. This is a 100mm lens. Zoom lenses would work, whatever you want, depending on what field of view and what parts of the sky you want to capture with that. And then you need some sort of a cable release. If you try and release the cable by pushing down the button, you can do that, or you can put a timer that will have the exposure taken shortly after you push down the button. But you can't keep the camera open, you can't keep the shutter open while you have your finger on the button. So you need some sort of a cable release. Now digitally, these are what they look like. This one happens to be called an intervalometer. It does other things than open the shutter. But there's a button here, you just push the button, the cable keeps the camera from vibrating, keeps the stars from shaking. So you just push the button, and the camera shutter will stay open as long as you need it to. You can program it to stay open for a certain amount of time. You can program it to take a certain number of pictures. You can do a lot of things with it. But you'll need something like that to keep the camera steady while you're taking the picture. Okay, so we talked about it. You attach the camera to the tripod. You're pointed to an interesting section of the sky. You take your shot. Actually, you want to take a couple of shots to kind of orient the camera the way you want, make sure you've got the exposures right, and we'll talk about how to do that in a minute. The longer exposures will give you a longer trail, but it also is more subject to sky glow. If you're in a light polluted area, you take a long exposure, the light pollution is going to overwhelm the stars. So you have to play with that a little bit. Sometimes you can reduce the ISO or the aperture to make the camera less sensitive. The stars are usually going to be bright enough to give you enough light over the period of time, but it'll reduce the amount of sky glow that you have. About 3 minutes, you're only going to get 3 minutes of exposure is 0.75 of a degree, 45 minutes of arc, which you can see is not very much of a streak. Over 10 minutes, you're going to get a longer streak, and over an hour, you'll get even longer. But when you start taking single images that are an hour long, you're going to have to worry about how much light pollution or sky glow is affecting your image. That's why you want to take several images, you want to take some test images and see how it goes. If I wanted to take a longer image and get longer trails, I would use in this case, a less sensitive film, or if I'm taking digital, I'll use a lower ISO number, or I'll stop down the aperture so that I get less light coming in, but the stars are usually going to be bright enough to give you enough to take a decent image. When I was preparing for the talk a couple of months ago, I took a single 1.5-minute image. Again, the big differ is up here, a bit of a different orientation. I took a single 1.5-minute image, and again, you don't see very much movement. But then I took a series of 8 of them, and in 12 minutes, when I stacked all those pictures together, in 12 minutes I got a fairly nice presentation of the rotation of the Earth. I was out in New Mexico some years ago, and I took a 3-minute, again, just on a tripod, I took a 3-minute image of the sky because I thought I saw the zodiacal light. The zodiacal light is a reflection of the sunlight off the dust that's in orbit around the sun. And you can see that at certain times of the year as a triangular shape. It's called a false dawn sometimes. It's a triangular shape that appears to follow the ecliptic. Because I was using film, I couldn't exactly see what I was doing or what I was getting, so I took a 10-minute shot. And while the star trails are really nice, it seems to me that I've overwhelmed the zodiacal light. So in terms of these two, that would be my preference for showing the zodiacal light. But you can see a pretty good representation of star trails. Again, decrease the ISO, the sensitivity of your camera to reduce the sky glow and allow you to get longer exposures. There's another trick you can use, it's called a hat trick. Start the image, then cover the camera with a hat for a couple minutes, and then take it away. And what that'll give, what it'll show you is the star as a relatively single point of light, and then you'll see the trail that goes behind it. I don't have any examples of that because I've not done it, or I can't find any pictures of where I've done it. But it basically allows you to see the constellations a little bit easier because that star is a single point that has a trail behind it. Just something else you can try. And again, illuminating the foreground with a light source. We've talked about star trails. The next category of things you can use to get started with are bright objects in the sky. You can photograph the sun. You've got to be careful that you use a proper filter. There are photographic filters, there are visual filters. Visual filters are a little darker than photographic. Solar photographic filters, visual filters typically filter out more light. You can pretty much use either one of them to take photographs because there's usually enough light with the visual to be able to take pictures of the sun. But you can take pictures of the sun, you can take pictures of the moon, solar eclipses, lunar eclipses. The moon is constantly changing. You can always get different pictures, different aspects of the moon. If you know where to look, you can get pictures of asteroids and comets. Meteor showers are very, very interesting. Usually, though, I found that unless the meteors that you're capturing are really bright, it's a hit and miss proposition. The Leonids that year were amazing, and I got a lot of really nice pictures of meteors, but most meteor showers, they're relatively sparse, and most of the meteors are relatively dim. But by all means, just do it. Go out and set up the camera, put it on a tripod, open it up, and point it at a section of the sky. All you're going to do is waste electrons. Maybe you'll get a really nice shot of a meteor streaking through and having a little fireball at the end of your picture. And really pay off. And of course, aurora are another thing. We don't see them too much around here. Again, not much difference in terms of what you need. The camera, the tripod, and the lens, the cable release. But if you're going to take pictures of the sun, you need a front filter for your telescope. The filter should go on the front of the telescope. Some cheap telescopes will have a filter that you can screw into the eyepiece. Don't ever, ever, ever use those. Because of the amount of heat that's going to hit that, they're going to thermally expand and crack. I had it happen to a friend of mine. Fortunately, he was all right. We were up in the high desert in Victorville, California, looking at the sun with one of these screw-in filters that goes on the eyepiece. It cracked. He backed away really quickly, and his eyes were okay, but he very easily could have damaged part of his retina. Don't ever use those back-end filters on your telescope. Filter always with the front. Okay, field of view. How much of the sky can you get with whatever kind of lens that you're going to use? Over here, you can see that the focal length of the lens. Right now, I had 100 millimeter on there. 100 millimeter doesn't even show up on this table. 100 millimeter lens. But with a 1,000 millimeter lens, I'm going to get 1.4 degree by about 2 degrees field of view of the sky. Now that's with a full frame 35 millimeter chip. Most DSLRs today use what's called an APS chip. An APS-C is about 60% the size 5 millimeter frame. So you're going to have to take for example, use the 35 millimeter, you've got to multiply that by 60%, and the field of view you'll get with an APS chip in your camera is going to be a little bit less. Use the proper solar filter, take test shots. Short exposures to avoid smearing. How short can you take? We'll talk about that here in a little bit when we show you something else. And then try to include foreground objects in it. It makes the picture more interesting, I think. If you can put a tree in it or a rock formation or a house or something like that, it kind of makes it more interesting. And then focus carefully. Canon cameras and I think Nikon cameras have something called live view, where you can take the picture, where it takes the picture and shows it to you on the back of the camera, and then you can zoom in on that 10 times. That's usually enough to get a pretty good focus for the pictures that I take. But there are other ways to do that, and one of them is called a back-knob mask. This fits over the front of your telescope. If this were the telescope, it would fit in the front aperture of your telescope, and it creates a diffraction pattern. I'd have to explain, if I explained to you how it works, I would have to say that it's magic. If you put this on the front of your telescope and you point it at a bright star, you'll get this X pattern, and then you get a beam of light that goes through the center. And as you turn the focusing knob, that beam of light moves from one side to the other side of that X. When it's exactly in the center, that's when the magic happens. It's focused. I don't know why, it just is. Okay, now I'm sure there are people in this club who can explain why, but I just prefer to call it magic because it works. And as you're turning the focus knob left and right, you can see that beam, that center beam, moving back and forth. And when you get it right to the center, it's in focus. You can take pictures of whole constellations. I get a really nice framing of Orion with a 100mm lens. You get almost the whole main part of the constellations in there. You can do that with other familiar pictures. You can get asterisms, the summer triangles, really kind of big. It may be too big to do this. But there are some other smaller ones. There's Bronchi's cluster, which is called a coat hanger. If you get a smaller field of view, you can get really nice images of that. One of my favorite is called the ET cluster. It used to be called the Owl cluster. But if you look at it, it's great for star parties. If you look at it, there's two bright stars that represent the eyes, and there's ET sitting out there with his arms, short, stubby little legs. So there's all kinds of neat things that you can take pictures of into that category. Again, same kind of things. You need a camera, shutter release. For the constellations, you need a moderately wide-angle lens and a sturdy tripod. But for smaller asterisms, you're going to need some way to track the sky. Because most of the smaller asterisms are relatively dim stars. You're going to have to take longer exposures. You're going to have some way for it to track the sky. Either piggybacking it on a driven telescope. There's also a couple of devices out there, if you have the money to invest, that are guiding, tracking. They will track the sky. They will follow the sky. That's not an active tracking method, but they basically turn the telescope or turn your camera usually on some sort of a ball head or some sort of mount at the same rate that the Earth is turning, so it's backing out the motion of the Earth, and it can go up to probably 200 or 300 millimeters if you've got it properly polar aligned, and they work pretty well. They're not as expensive as a full-size telescope, but then again they're limited to astrophotography and things like that. How long can you take a picture? It depends on a couple of things. It then depends on how high in declination you're looking at. We all know that objects near the pole don't move very fast. Polaris almost doesn't move at all. Stars down near the equator, the celestial equator, move relatively quickly in terms of linear distance. So how much magnification can you get? What focal length lens can you use? How long can you take a shot in order to keep the stars from trailing? Well, this makes the assumption that with a 50mm lens and a 20-second exposure, that's adequate. The smearing you get with that combination is adequate. So there's a 50mm lens at 0 degrees declination for 20 seconds. That's what it gives you. So if you want to use a wide-angle lens, like an 18mm lens, you can take up to a 55mm shot. 55-second shot at the equator. And if you want to go take something that's higher in elevation, you can take as long as 3-4 minutes. Yeah, 3 or 4 minutes without having too much smearing at all. Again, as you get higher magnifications, the longer focal length telescopes, you have to limit yourself to shorter durations. But the rule of thumb is something like this. If you take the focal length of your lens, or telescope, and divide it into 700, that's how many seconds you can take a shot without it smearing significantly on your image. So if I have a 100mm lens, which is what I have here, I can take about a 7-second shot. Again, that's over here. 7-second shot, and I won't get significant smearing. If I go further up in elevation, further up in declination, then I can take a longer shot. But that's a good rule of thumb to get you in the ballpark. Select your target, aim, frame, and focus. And by frame and focus, obviously focus, you know what I mean, but by framing it, sometimes you have to tweak the orientation of the camera. You have to turn the camera physically to get it to fit in an orientation that makes it look nice on the picture. So sometimes it takes a series of test shots to be able to do that. Shoot your test images and check for exposure, trailing stars, all other stuff. And then finally, when you're ready, you shoot your image or your series of subs that you're going to go back later and process. We worry a lot about dew on our telescopes because it can very quickly shorten a night of observing. If you're taking pictures of things through your camera, you have to worry about dew just as well. One solution is to go out and buy dew heaters. You know, we have dew heaters for our camera. Our telescopes, and they plug in and they're electrical, and they basically bring the temperature of the lens or the mirror up to just slightly above the dew point, and it keeps the dew from forming. If I'm going out for a quick astrophotography night and I don't have a telescope, but I don't have a dew heater, what else am I going to do? Well, I buy a series of these chemical hand warmers. You can find them in a bunch of stores. You open them up, there's basically iron oxide in there, or at least there's some sort of iron in there. It reacts with the air, creates rust, but it stays within the container. It creates a little bit of heat, not a whole lot, but just enough. And so if I take that and use a rubber band and put this around the lens of my telescope, that's usually going to be enough heat for enough time to keep the dew off my camera lens for as much as I need, for as long as I can stand to be out there taking pictures. It's a very simple solution. You can use it on your telescopes too. It's great for eyepieces and telrads and a whole bunch of other things. These things are relatively cheap and very effective in terms of keeping dew under control. Shifted focus. You saw it bumped a couple of times in the pictures that I've taken. We saw what we think was mirror shift, because that was an SCT. As it moved through the sky, the mirror may have shifted a little bit. So you have to keep checking the focus. All right, take several test shots. Check the histogram. We're going to talk about histograms in just a minute. Avoid a wide open camera lens. Stop it down if you're getting foam on the edges. Warm your lenses. Have an extra camera battery or external power. And take exposures that will minimize sky glow. What do we mean by that? First of all, you can take shorter images, or you can take images that are stopped down in ISO. But if you wait till later in the evening or early in the morning, some of the businesses, some of the street lights, the sky seems to get darker the later at night you get. There's less sky glow, there's less pollution because people have shut off their lights as they've gone to bed. I don't know why it is. Some of the places are still open, like Sheetz is open 24 hours a day. But some of the places, the sky seems to get darker as you go on. Also, if you're shooting near the meridian, shooting straight overhead and near the zenith, rather, you're looking through less atmosphere, so you're going to be less susceptible to light pollution and to sky glow in your camera. So if the object you want to take is here, wait a couple hours till it gets up here, because especially if it's in that area right over your head, it's going to be a lot darker and a lot less light pollution. You'll get a lot more signal to noise for your. If you look on the back of most digital single lens reflex cameras, it gives you the option to look at the picture you just took. And in my camera, if I hit the information button, it'll give me some details about what the exposure was and what the aperture was and a whole bunch of other stuff. And if I hit it again, then I will get this little chart on the back. It's called a histogram. It gives you a wealth of information that you need to shoot pictures correctly. As it counts, it gives you a representation of the number of pixels, that's the height of the bar, of black. If it's over here, that's the number of pictures that are black, number of pixels that are black, and that's the number of pixels that are pure white. So as this picture over here is telling you that most of the pixels are within 20 to 40% of black to white. So I can see that this exposure is about right because I don't have data being lost over here and I don't have any pixels that are super saturated. So when I go back and process this, I can have a good solid dynamic range. This is a test picture that I took of Eta Carina, and you can see it's a fairly dim image, but you can also see that most of the pixels are within that first fifth of brightness. They're really pretty dim. There's only a few, probably some of these brighter stars, there's only a few that actually get beyond that. Okay. So I extended the exposure. This one was, where is it?
120 seconds.
Oh yeah, at the top there, 120 seconds. So I extended the exposure to 300 seconds, about 5 minutes. And now my histogram has moved from way over here to about there. It's still not beyond the 1/5 mark, but it's better. If I had to stop there because of various reasons of light pollution or tracking or something like this, I could probably do something with that image. Well, that's what the histogram can tell you. It can tell you how long to shoot so that you're getting enough information and yet you're not being overwhelmed by sky glow. Bright, deep sky objects. These are things that you can take pictures of. Again, these are fairly advanced techniques, not quite the entry-level kinds of things that you want. But you can take pictures of bright nebula, and you can take pictures of large open globular clusters. The fainter deep sky objects, well, the bright ones are really pretty. There's only a few of them, and sometimes we get, we want to take pictures of some other things. The faint fuzzies that are out there are the vast majority of things that are out there, and they can get really, really pretty. Don't start taking pictures of these things. If you're just getting into astrophotography, don't start here. Now, you can if you want to, but your pictures are going to have problems, and don't be disappointed. Celebrate your success if you start taking pictures of something like this, because you'll be getting something on your camera. You just have to understand that you have a whole bunch of problems that you have to solve first, that you would have solved had you started back with the star trails and the wide field pictures and so on. You'll learn to solve those problems, and when you get to this point, you'll be better able to handle the more difficult challenges that you get. So, if you don't mind, don't start here. If you want to start here, that's fine, but you'll learn that there are some other things that you have to take care of. So, what do you need to take pictures of deep sky objects? Well, you need some sort of a guided mount, either a fork mount, a German equatorial mount, something that will be able to track the sky for a long period of time without introducing rotation. You need some sort of a telescope, a camera of some kind, dew heaters to keep the dew off, you need power source of the camera mount, you need an autoscope, autoguider, you need a whole bunch of other stuff that I probably don't have listed here. When I get out onto the field to take pictures, from the time I step out of my car to the time I'm ready to take pictures, it takes me about 2 hours, an hour to 2 hours to set everything up, to put it all in place, to get all the pieces working together. It's time well spent because I can take pictures, very nice pictures after that. But it takes a while to put it all together and make it work. Now, how do you do it? Here's how you do it. You got that? I'm going to go through that list. These are all steps. There's probably a lot more that you have to take to be able to get deep sky pictures. Don't be discouraged by this list. This list becomes second nature to you once you solved all those other problems. Once you realize all the things, you solved all the other things that you had to do to get to this point, the things that you have to do here are just second nature. They become part of your routine. So don't be discouraged or challenged overly by this list. It's just what you got to do. Because you've got blue stars, you've got yellow stars, you've got orange stars. Why don't you have green stars? When you see a red star, you basically shifted the spectrum the spectrum of the star is shifted to the red, and so it's not very strong in the yellow and blue side. So you see red. When you see a blue star, it's shifted to the higher end of the frequency spectrum, so all you see is the blue light. You don't see much of the longer frequencies, and so it looks blue to you. But if you were to see green, which is in the center of the visual spectrum, you would see all the frequencies of light, and so basically all you see is a white star. So you got to know what your gear can do and know what it can't do. You know you don't want to go out on a windy night or a night with poor seeing if you're trying to get high detail. You want to get the basics right by starting out, if you haven't done it before, starting out using and doing simple things. Piggyback astrophotography, star trails, those kind of things. They give you the talents, the skills that you need to solve the problems that you're going to eventually run into later on. Such as focusing and framing. Each exposure, you want to expose each picture, each image as long as you can without drowning it out by all the sky glow that you run into. That yellow telescope that I showed you had an f2.8, had a 4-degree field of view. I can't use that around here. By the time I take a 30-second image with that, the image is blown out by the sky glows. Normal DSLRs come with a filter in front of it to block out most of the infrared light, because we don't see an infrared, and they want the images that we see to match the images that it takes to match what we see, so that the colors come out as close to real as you can. But what that does is it cuts off the frequency of light that's emitted by hydrogen, the hydrogen alpha line, and that's where we see a lot of the light that we look at. All the things that are red in the sky typically are hydrogen alpha light, and this camera, as bought from the manufacturer, blocks that out. So if you send it off or you buy it modified, they put a different filter in front, and it becomes 80% more efficient in collecting that hydrogen alpha light than if you have a stock camera. So if you're interested in astrophotographs, and you can still use this for terrestrial photographs, you just have to make a few little adjustments when you're taking pictures. So if you want to take pictures with your DSLR, and you want to take nebula pictures, I recommend getting one that's been modified to be more sensitive in the hydrogen alpha range. Filters, light pollution filters, where it helps. If you put a filter, you're basically blocking out light. In some cases that's good because it's light you don't want, but in some cases it's not because you're cutting down the amount of light like galaxies and things like that you have. So you have to take longer exposures. That complicates your process. But they can be very, very helpful. If you have the ability to track and guide, hydrogen alpha or oxygen-3 filters do a very good job of bringing out the nebulosity in some of the objects that we look at. Even visually, if you haven't tried some of those filters, try looking at some of the nebula with them. They're really amazing. A lot of times you'll see vignetting on the sides of the camera. The sides of the image will be darker on the corners than in the center. Well, if you take flats, you can basically process that away so that the entire field of view is properly exposed and exposed properly, exposed to the point where you can see the entire field as well as you can the center. All right, other suggestions. Share your photos. There's Byron Bergert's imaging group that meets once a month at various libraries around town. Take your pictures to them. Go to those meetings and have them help you explore how to process them. Put your photos online and have people comment on them. There's a bunch of places you can do that. The NOVAC website is one of them. There's a bunch of other places. Buy used equipment. Most people take very good care of their gear because they know they're going to want to sell it, and if it's not in good shape, they're not going to be able to get a good price for it. So go on Astromart or Cloudy Nights and buy used gear. Resell what you don't need. Have a tendency to do that, but try it, it's nice. It'd be more like renting your gear. Start a discretionary fund. You get agreement with your significant other that you're going to put a certain amount of money away every month so that when the time comes to buy that gee whiz doodad thing that you want, that's going to solve all your astrophotography problems, so to speak, you'll have the money to do that and you won't have to use the rent money. Keep trying. Gather data on old targets you've taken before. Now that you've got new skills or new equipment, go back and take pictures of those again. And test out new gear. You got to understand what's wrong with your current images in order to take better images in the future. Test, analyze, and fix. We've gone through a series of steps here to show you pictures that I've taken that came out poorly, but by solving the problems that those pictures created or exposed, I was able to go on and take better and better pictures. Don't think that you can buy your way out of the problem. The best solution is to figure out what the problem is and try and find another way around it. It took me 45 minutes of that eyepiece before I realized that wasn't the way for me to get longer exposures. It resulted in me getting an auto guider, and it's worked very well for me since then. But I tried a lot of different things before I realized that was the solution. There's a lot of, depending on the problem, there's a lot of ways to solve those problems without going out and buying new gear all the time. So if you do all those kind of things, you're going to have images that you'll be proud to share with people. The point is, take the gear that you have, go out and just do it. That's my Nike swoosh, by the way. Just do it. Okay? Just take pictures, process them, figure them out, share them with others, and figure out how to do it better next time.